As you watch this notes presentation, please take out a sheet of notebook paper, put your name in the top right corner, and take notes as we continue through the presentation. It's important to pause the video and record things that you believe are important and things that you would like to remember for your upcoming retake. The first thing that we're going to talk about are types of running water. Running water is the most important agent in eroding, transporting, and depositing sediment in developing landscapes. The first thing we're going to talk about is a stream. An important thing to note about a stream is that they rarely dry up. They are a channel along which water is continually flowing down a slope. Remember that streams often start in the mountains. As they flow together, they form larger and larger bodies of flowing water. A large stream is often called a river. A vocabulary word that I would like you to make note of is headwaters. This is a place where streams start, and like we said on the previous page, they often start in the mountains. Streams can also begin when water rapidly flows over a slope or steep land. Eventually that erodes into a V-shaped valley. The next is a mouth or delta. This is simply where a stream enters a sea. It's important to understand that usually a lot of land or sediment will deposit in this area, therefore causing deposition. Remember that deposition is a constructive force, meaning that we're building up the land or adding new land. As water falls through rain, sleet, snow, it makes its way to several different bodies of waters, whether that's a stream, a lake, a creek, a river, but often sometimes rain does not make it to those confined locations. Anything that moves across land that's not confined is called sheet wash. When rain falls, the water travels over land to make its way to different bodies of water. This is called a watershed. So again, a watershed is simply the total amount of land that water collects on or travels through in order to get to a body of water. Watersheds are actually very large. One of the largest watersheds is in the United States and takes up several states. Watersheds can be separated by a divide, which we'll talk about on the next page. A divide simply separates the water flow over land. Usually these are high levels of land, what causes the water to go in opposite directions. We have the continental divide in the United States, which causes part of the water that falls to go towards the Pacific, and the other part of the water travels in different routes to eventually get to the Atlantic Ocean. On the next 3 slides, we're going to talk about different drainage patterns. Drainage patterns are simply formed by streams and all of the branches that come off. These different shapes are controlled by the rock or sediment, and it often tells you a lot about the bedrock that it's formed in. The first drainage pattern that we'll talk about is dendritic. It simply looks like a tree branch. They often start up in the mountains, that would represent this area up here, and eventually they combine and make their way towards down the slope. The next one is radial. This often forms on features like a volcano or a mountain, where it starts at a point up high and they fall towards down the slope. The last one is rectangular. These are often 90-degree angles and is due to fractured bedrock, which serves as pathways for streams. The next vocabulary word that we are going to talk about is velocity. Velocity is simply the speed of the stream. There are 2 different areas that we would like you to pay attention to. On a straight segment, meaning the stream or river is going straight, the highest velocity is going to be smack dab in the middle. If you look to the diagram labeled A, you can see highest velocity is right in the middle. This simply means that in the middle you will find the fastest flowing water. When you go around a bend, meander, or curve, the fastest velocity or the highest velocity will be on the outside of the curve. That is shown in section B and C. If you think about a water slide, when you go around a curve, your body is going to go around the outside. That's what helps you to go the fastest down a water slide. It's the same with a stream or river. As the water makes its way around the bend, it pushes along this outside, having the highest velocity or speed. Another important vocabulary word is gradient. Gradient is simply the steepness or the slope of a stream. If the slope or steepness is higher, that means the stream is going to have a higher velocity, a higher speed. This makes sense even if we relate it to sled riding. If you want to be faster on your sled, you usually go to a higher hill or a more steep hill. It's the same with streams. When a stream has a high gradient, it's going to have a high velocity. There are things that cause a stream to go fast or slow. One thing that can slow down a stream is friction. Depending on what's located on the bottom, boulders, rocks, sediment, that could cause a stream to slow down. A smooth channel bottom is going to cause a stream to go faster. The fastest type of stream would be a narrow stream that is deep. The picture in the middle shows an example of that. Discharge is the volume of water that flows past a given point per unit of time. This is found by looking at how wide the stream is, how deep the stream is, and what is the average speed of the stream. From here, we can find out how much water flows past an area in a certain amount of time. On the next couple slides, we are going to talk about different deposits that are made by streams. These are things that add land. They're constructive forces because we're building up the land that's currently there. The first type of deposit made by a stream is called a bar deposit. This is simply sand or gravel that has been deposited into the center of the channel. Meandering stream is simply a stream that has a lot of curves, twists, or turns. We talked about earlier that erosion always happens on the outside, and because of that, deposition always happens on the inside, which causes it to be a constructive force. On both sides of the stream channel, you have what's called the floodplain. This simply means that when the banks overflow, this area is covered in water. A lot of sediment will then deposit onto the land once the water goes back towards the stream. Because this is a deposit, we're adding to the land. It's called deposition, and it's a constructive force. Earlier we talked about a delta as it being where the stream enters a large body of water. Once that happens, it's forced to drop all of the sediment that it's collected along its path. The last deposit made by a stream is called an alluvial fan. This is when a stream comes out of a narrow mountain range, and all of a sudden the sediment spreads out and emerges from the canyon, and that's where it drops all of the sediment. On your concept map, there are some important things that you would need to recognize. On the top section, we look at different types of running water. Notice the difference between headwaters and delta. Headwaters is where a stream starts, whereas delta is basically where it ends, where it enters a larger body of water. Over on the right-hand side, we talked about 3 different types of drainage patterns. Remember that dendritic is the one that looks like a tree branch. Radial looks as if it's coming from a conical feature, basically a volcano or a mountain. It looks like a circle is coming its way down. And rectangular has a lot of 90-degree angles. Along the bottom, we talk about different types of stream erosion. We have velocity, which is the speed of the stream, gradient, which is the slope. Channel shape can affect the speed. The fastest stream is going to be narrow and deep. Then we also talked about discharge, which is the amount of water that travels past a certain point in a certain amount of time. Finally, the last big section is over all the way to the left. These are all examples of deposits made by streams. Notice that there are several different ways, all of which are important to adding to our land or being a constructive force.